So basically, what are use case diagrams? Use case diagrams are basically showing what type of functionalities are available for the users to use or whoever is interacting with the system. So basically, use case diagram is made first at initial level when we are designing diagrams for our system. At the first diagram that is made is use case diagram. So the importance of use case diagram is that basically it helps the developers, it helps the requirement analyst, the it helps in logical designing. Basically, it helps in both um, all these people for designing the system or for understanding what actually functionalities the system would have. So basically, use case diagram. The first thing we all need to know is that use case diagrams, they only tell you what the system should do and not how it will do it. So this is not the concern, but this is the concern what the system would do. And this basically shows that what type of functionalities are there in the system, and these functionalities are available for people who are using this system. So this is the first definition. Continuing with this definition, based on basically use case diagrams are contextual diagrams. These are based on scenarios. So these diagrams, they are also known as context diagrams. So in whenever we are making use case diagram or sequence diagram or any diagram, the context is very important. So they are scenario based diagrams. Also, it's a formal way of representing the system functionalities. This is very important. So basically, what functionalities are available from user perspective or from the perspective of whoever is using the system. So representing how a system interacts with its environment. System, whatever software system, how it interacts with its environments. And um, we have user and actors, and there are relationships between user and use cases and the actors. So use cases and the actors have certain relationship. This is being shown in use case diagram. So there are certain guidelines that need to be kept in mind. So these guidelines, first guideline is basically use case show ideally begin with a verb. So basically, we should prefer verb or we should prefer a noun plus verb, but only a verb is also enough for to be used in a use case diagram. For example, here we have an example like we should not use the word register, which is an open-ended word. Register who exactly? So there might be confusion when we are using this type of word. So instead of using this word, we can write register new user. Now this has a complete meaning. So we should use these words instead. Avoid showing communication in the use case diagram because obviously it's not a communication diagram, it's not a sequence diagram. So we should avoid showing communication or sequences in this diagram. Further, we should use words like student, not like these words Sam and things like this. Okay. Last point, which is very important, do not show behavior in use case diagram. Initially, I have said that we are not focusing on how it will like how the functionalities will execute. Rather, we are focused on what functionalities are there in the system, not how they will execute. So in use case diagram, these things are important. Our actor, whoever is using the system or whoever is interacting with the system, use cases, and the relationship. There are four types of relationship: simple association, then we have generalization, sorry, then we have include and extend. Both are shown in this way, but the arrow is different. We will talk about this with an example. And system boundary, which is very important that we need to make system boundary. On top of the system boundary or on the right side, we need to mention the name of the system. So let's just discuss these things. First is the actor. Actor, either you can show the actor by a human figure. Actor could be your human figure or a machine which is interacting with the system, an external system, a scenario based, or your organization units. So there are two types of actors, primary actor and secondary actor. So what's the difference between primary actor and secondary actor? When we draw system boundary, we write the name of the system. We prefer that primary actor should be placed on the left side, and on the right side we place our secondary actor. So what's the difference between these two? Primary actor is basically the one who is providing information to the system. So the one who provide or receive information from the system is known as primary actor. They provide information or they receive information. Like they provide information like like for login, they will provide information. And when they are viewing something, view courses, let's suppose, so they are viewing this information, so they are primary actor. On the contrary, we have secondary actors, which are also known as passive actors. So they are the one who receive stimuli. Basically, let's take an example. Just let me add a blank slide. So in case the student is basically um, student would log in. Sorry, what's the important thing is to write the name. This is basically student portal. So on student portal, this is the system boundary, and this is the name of the system. User can do basically login, and they can basically file an application. So in this scenario, when user is filing an application on the system, this application would be received by admin. So in this scenario, this student is the primary actor, and the other end which is receiving this information is the secondary actor. So I hope primary and secondary actor is clear. Now we have what the actor would do. Basically, the actor, they are interested in using the system. They provide information or receive this information through the interfaces, or they basically exchange data, or they take information from the system. Then we have this notation, which is known as your use case notation. So, and it consists of functionalities. This is the important point. Then there are 4 types of relationships. This is associations shown by straight line. Then we have generalization. Then we have include and extend. So let's just discuss these. Simple association, it means that we are using this, often referred as a communication association. So communication between the actor and the use case. Then we have generalization. Basically, generalization is used when we want to show the concept of inheritance. Inheritance means that basically like, the parent class has certain attributes and child class has those attributes as well. So for example, in this scenario, search is the parent class, and these are the child classes, search by author or search by book number, you can say. So both these inherit the same properties of this parent class. Basically, they provide you the functionality of searching. So we can show that these two classes basically inherit the same properties as this, so functionalities. So these two methods inherit the same properties as this parent class. So we can show this by this generalization. It is basically a triangular arrow and a straight line. So then we have include and extend. Include mean that this use case will require this for executing it. It's a must part of it. So the must part is known, we show it by include. Let's take an example. For borrowing a book from the library, the included part is to check whether the book is reserved or not. First thing. Second thing is check if some fine is imposed or not. If these two are important thing, are the must part that needs to be done. Also, students have a very close look. The arrow is towards the child, the arrow is towards that must part which is included. So we write include like this. Why? Because it's known as a stereotype. What's the meaning of stereotype? It means that these functionalities, these are basically outside these use cases. So we basically use these functionalities. So this borrow book has must part, which is to check if the book was previously reserved or not, and to check whether there was some fine imposed or not. Now we have extend. So students have a close look in extend. The arrow is towards the opposite side, not towards that other side. And extend, it means that this is an optional part. So let's take an example. Here we have used the extend. Basically, when user is searching for something, they have an option to request a book, but it's not a must part of it. Rather, it's an optional part. So in extend, the arrow is towards that class, and it's basically showing that this is the extended part of it. So here we have an example of extend. User can place phone calls, and they have the option to place a conference call. Similarly, they can receive a call, or they have an option of receiving the call, an additional call. So the arrow is towards here, and we write the extend here. Here we have example of both include and extend. So when user is applying for a course, take the example of Coursera. So when user is applying for a course, they must log in. And when they are applying for a course, they can see course particulars or course details when they are applying for a course. So this is the must part. Without login, they cannot apply for a course. And extend basically means that's an optional part. They can see the detail if they want to. That's an optional part. Now, system boundary. System boundary basically shows is shown by a rectangular is usually shown by a rectangle, and on top of it we usually place our the name of our like this, and on top we write the name of our system with which the user is interacting. So here we have an example like customer receives a checkout item. Let's just first we need to identify use cases, then boundary, then use cases that need to be placed, the actors and the relationship. Here we just going to the example. Basically, there's an initiator and a receiver inside this system boundary. Further, user simple straight line is used to show association and generate schedule. These are the different functionality that are available for the users. And here there's a slight mistake as well that the dotted line is not used for extend. If there are the user can edit constraints, so or provide constraint. With that, there's an extended part. They can edit constraint. They can either provide constraint or they can edit constraints as well. So further, the same example, book borrowing. So a librarian, they can borrow books, and it has included part that you need to check fine or check. These are the must parts. Then we have this thing that the student, they can basically request for a book, and an extended part with this is they can also search for a book and they can request for a book. But it's not compulsory that if they are searching for a specific thing that they would must request for a book. They might request for a book. That's an optional part here. But they can the user, they can search by either call number, they can search by author, or they can search by title. These are the different options of search. So these three options, they inherit the same property as this search, and along with search, the extended part is they can request for a book. But when they are requesting for a book, it must check the availability in library because it's the included part here. Further, again, you can show the generalization like this with like here. And here is another example of extend. User can make payment by these different options, by PayPal, by EFT, or by credit card. These are different options. So they are in extend. So further, if we move further, there is another example, and based on this example, you can see that a student, they have option. They can basically register in a class or class registration. This is the option which is available for students, and teachers, they have the option that they can select the courses they want to teach, or they can request for course roster. Further, there's a registrar and professor. These are our secondary actor because they are part of the system. And registrar, they have these options that they can basically maintain professor information, they can maintain student information, they can maintain course information, and they can create course catalog. Now, students, considering your then basically LMS example, this is a system boundary, and on top here we need to write system name. Let me just take example PAF-IC. So in this scenario, what we have the student actor. So we can modify the name by just double clicking here, write student here. And this is basically our primary actor. Now we have a secondary actor as well. Here, secondary actor might be HOP or the advisor, the head of the program, or the advisor. So what are different functionalities that are available? These are the different functionalities that are available. Student, they can log in the system. And basically, I'm considering this use case diagram and the context of this diagram is student can launch an application on the portal. So how the procedure is. Um, they can basically file application. So students have a closed look that login, it's a verb, and it has a complete meaning, login in this system. So it has a complete meaning. Here, uh, the alone application word would be insufficient. So file application is basically showing that student can basically file an application or forward an application or basically launch an application on the system. So these are the different options that are available for users, and they can basically view their application or view the progress on the application or receive the comments from the application. And what are different options that are available for the advisor? They can basically approve or reject application. And this option is also available for the HOP. So based on this scenario, the advisor and the HOP, these are the ends which will receive the information. And they are the ends which will receive the information, so they are secondary actors. So the primary actor in this case is our student. So student, they can basically launch an application. First, they need to do login. So after login, what they can do, they can basically file an application. And the third thing they can do is basically they can view their application. So the HOP, they have these options that they can basically approve or reject their application. And the same options are available for advisor. So whatever application that has been filed, it will be approved or rejected by the advisor. So, or you can file application, it will be, so this is how it is. So there are some included and extend part that needs to be added. So for include, whenever there is an option of login, authenticate is an included part here. So authenticate is an included part. Also, it requires an arrow. Sorry, it's two words. The included part, and we need to write include here. So these this is how the procedure works. So they can basically view application and basically the advisor, the HOP is the receiving end. We can basically skip this part. Advisor is basically the one who is receiving this information or has the authority to reject or accept the application. So they have this approve or reject the application option. So when they file an application, so it will for its approval or for rejection, and after filing an application, then it would be approved or rejected by the advisor. So student can basically create an account or they can log in. In login, we have the included part which is authenticate. A student can basically register in courses or student can view registration. So when they register in course, the included part is check fee. The second is check prereq. These are the included part because students cannot register in a course if they have not done completed the prereq of it. Also, students need to check the fee for a course because they need to submit it. So check fee is an included part of course registration. After this, they can basically view registration and students can submit application. Based on their submitted application, it would either go to the advisor or an HOP or whatever, and they basically will approve the application and ultimately it would go to the administration where the final approval will be done. So in this diagram, my context is basically when students are registering in a course, their final application would be submitted to the administration and they will basically approve or reject the application. And the last option, which is basically logout. So this is available for the students. So it's also connected by an association, a straight line. Students kindly don't make an arrow line here. So it's a simple association line which is connected with the student with a logout. So this is how you're going to create a use case diagram for the context where student needs to register in a course. So these diagrams, they are known as context diagrams. It's very important. What's the scenario? Based on the scenario, you make the diagram. If the scenario would be different, basically how students are filing an application on the system, then it would go to advisor and then it would go to HOP. So basically the procedure is different in that scenario. So the diagram would be different. This scenario is built for course registration. So that's different. So I hope everything is clear related to primary actor, secondary actor, how you're going to use include, how you're going to use extend, how you're going to make system boundary, and how you're going to add functionalities and simple associations in your diagram. I hope everything is clear. So that's it.